Okay, hi guys. So in this lecture we'll be seeing center of symmetry. So let me write down the heading. Center of symmetry. Okay. So in center of symmetry, it is simply if all the like groups are connected by an axis and the axis passes through the center of the organic compound and the like groups are equivalent from the center, then this is known as center of symmetry. Okay. So let me write it down. If all like groups are connected by an axis and the axis passes through the center of the organic compound and the like groups are equidistant from center, then it is known as center of symmetry. So center of symmetry is absent in Fisher projection and center of symmetry is absent in eclipse conformation. So center of symmetry is absent in Fisher conformation or in Fisher projection, and secondly, center of symmetry is absent in eclipsed conformation. Okay, so let us see some of the examples of center of symmetry. So we have this compound in which F is attached here, Cl is attached here, Cl is attached here, and F is attached here. So we can see that obviously there is a plane of symmetry in this compound, and let's look. This is the plane of symmetry, which cuts all the atoms into two halves. Okay, this is the plane of symmetry, and what is the center of symmetry? Is there an axis which passes through the center of the organic compound and all the like groups are equidistant from the center? Yes, this is indeed the case. Let me draw it here. All the like atoms are equal distance from center of symmetry, so center of symmetry is also there in this compound. Okay, let us draw this compound. So is center of symmetry there in this compound? Yes, center of symmetry is obviously there in this compound. How? From the center of the compound we can find Cl and H equidistance, and obviously the horizontal plane is the POS. So POS is there and COS is also there. Okay, so let's have a look at this compound. So is center of symmetry there in this compound? This is the POS, so POS is there. Center of symmetry is, oh sorry, POS is also not there in this compound, because the Cl, the mirror image of Cl is missing here, because H is here on the first carbon atom. So Cl is not present, hence POS is not there, COS is also not there, because as we have already written that center of symmetry is absent in Fischer conformation. Okay, let us look at some more example. We have HCl and CS3. So is center of symmetry there in this compound? No. Why? Because it's eclipsed conformation. Okay, let's look at this example. So is center of symmetry there in this compound? And this is dash. Center of symmetry is yes there in this compound. Why? Oxygen are equidistant, the methyl groups are equidistant. So center of symmetry is there in this compound. Okay, so let us look at this compound, whether the center of symmetry is there in this compound or not. H, Cl, H and Cl. Center of symmetry is not there in this compound. Whether plane of symmetry is there in this compound? No. So if no symmetry is there in this compound, this cannot be a meso compound also, right? Okay, so next question is you have to draw stereoisomers of gamexane or lindane or 666. So I'll just tell you what is gamexane or lindane. Okay, so the next question is draw stereoisomers of gamexane or or 666. Okay, so what are all these compounds? All these compounds are nothing but cyclohexane substituted with every carbon on every carbon atom it is substituted with a chloro group. This is gamexane or lindane or 666. Okay, so here we need to draw all the possible stereoisomers of gamexane. So stereoisomers can be, one would be all above the plane, second would be all except one is above the plane, third would be all except two are above the plane, fourth example would be change in position of the chloroatoms which are not above the plane. Okay, fifth one would be again changing the position, it can be here as well. Okay, sixth can be all except three are above the plane. Okay, seventh one can be changing the relative positions of three chloroatoms which are not above the plane. Again we can change the positions, something like this. Please make a note that 7th and 8th are actually mirror images of each other and are not superimposable. Okay. 9th one can be CL here. And chloro here. Okay, so these are the 9 stereoisomers of gamexene. So let us see in which of the following POS and COS is present or not. So in this case, POS is present, COS is not. In the second case, POS is present, COS is not. In the third case, COS obviously not. And if POS is present or not, yes, POS is present. This can be a POS, so POS is present. In the fourth case, POS is present, not COS. The fifth case, again POS is present, COS is absent. Now in the seventh case, I think COS and POS. Oh, in the sixth case, COS and POS are both available. In the seventh case, POS is not present and COS is also not present. Okay. In the eighth case, same, POS is not present and COS is also not present. In the ninth case, yes, POS is present and COS is also present. So with this we come to the end of this lecture. In the next lecture we'll be seeing some of more examples on the POS and COS of isomers of cyclopentane and other such examples, and then we'll be continuing on excess of symmetry. So till then, good luck and goodbye.